I'm doing WebSign 11b problem 8, which says two coplanar and concentric loops of wire carry currents of I1 is equal to 6.4 amps and I2 is equal to 2 amps in opposite directions as in the figure below. Let R1 equal 12 centimeters and R2 equal 8.9 centimeters. So this is the picture, and we have the two loops here. This is I1 and radius 1, radius 2, I2. So part A asks, what is the magnitude of the magnetic field at the center of the two loops? So first I had to figure out if they were in the same direction or in opposite directions, because that was going to determine if I was going to add or subtract them. So I used the right hand rule, and so first I did I2, and my thumb pointed down, and then my fingers were pointing out of the screen, so the magnetic field due to I2 at the center is out of the screen, and then I1 is into the screen. So we're going to be subtracting them since they're going in opposite directions. So first I just have the magnetic field is equal to I1 minus I2, and then I have magnetic field is equal to mu naught I1 over 4 pi r times theta. That's, I have no idea how to say it, Savart law. I probably just butchered that. I don't really know how to say it, but you know what I'm talking about, because that's obviously what this video is about. So that's for a curved wire where theta is the radians. And then minus, that's R1, mu naught I2 over 4 pi R2 times theta. So now plugging in values, 4 pi times 10 to the negative 7th, this is just a constant, times I1, which was 6.4 amps, over 4 pi times 0.12 meters, and make sure to recognize that these are both in centimeters and needs to be converted to meters, or else the answer will be off. Times, so for theta, since we're looking at the whole entire loop, it's going to be 2 pi, since when we look at something like the unit circle, it's for the whole circle, it's 2 pi. So multiply by 2 pi minus 4 pi times 10 to the negative 7th Teslas times meters per amp times 2 amps over 4 pi times radius 2, which is 0.089 meters, times 2 pi. And when you look at this, hold on. So the 2 pi, I don't know what I'm trying to say. Never mind. So this is going to cancel with this, and it's going to leave a 2 down here. Okay. And then this is equal to 19.4 microteslas. So I messed this up at first. I don't know why I had a 4 in the numerator too. But, so then like my answer was multiplied by 2. So I'm not sure where I got the 4 in the numerator from, but yeah. So that just messed up my answer, but other than that, there's nothing that really gave me any issues. So then the direction of the net magnetic field at the center of the 2 loops. So we determined that I is going in and I2, or I1 is going in and I2 is going out. So since we did I1 minus I2 and this answer came out positive, we know that I1 is bigger than I2, so the net magnetic field is going into the page because that's the direction of I1. Okay, and then part C, let R1 remain fixed at 12 centimeters and R2 be a variable. Determine the value of R2 such that the net field at the center of the loops is 0. So I just set the equation that I used before equal to 0. So U naught I1 over 4 pi R1 theta minus U naught I2 4 pi R2 theta is equal to 0. Then I just solve for R2 because that's what we're looking for. R2 is the variable and we need to find the value of R2. So that's what I'm solving for. So I have that is equal to R1 times I2 over I1. R2 is equal to 0.12 meters since R1 stayed the same. And then times 2 amps over 6.4 amps. And that answer is 3.75 centimeters. So that was pretty easy, just algebra and knowing to set this equal to 0. I forget what I was going to say earlier. Now it's going to bug me. Whatever, it's not that important. Okay. That's all. This problem wasn't super hard. It's just any mistakes would probably either be with changing this or messing up algebra somewhere. I don't really know. Just knowing how to use the right hand rule correctly. Yeah, that's all.